everyone, welcome to my channel. Today we are going to discuss some of the proofs of some special integrals. Overall, if you see, here are the list. There are total 7 special integral, okay, and we are going to discuss the proof of each of them. Okay, now I am going to do the proof of each of these 7 in 3 different videos. So in today's video I'll do the proof of this two. This will be part 1, okay, and of the other two this will be part 2, and the last 3 will be in the part 3. Okay, so make sure you watch all of the 3 parts to go through the proof of each of the formulas. Okay, so now let's just begin with the first proof here. So I'll just write the integral, that is I is equal to integration 1 upon x square plus a square dx. So we are going to evaluate, or we are going to prove the formula. So in that case you have to substitute, put x is equal to a tan theta. Okay, so here the tan theta becomes x upon a. When we differentiate this on both of this side, I'll directly write the differentiation form, which is sec square theta d theta, and the derivative of x will be 1 dx upon a. A is constant, so we'll keep this aside. Okay, now we will substitute in I. So this becomes, so instead of dx, instead of the value of dx will be a sec square theta d theta. Okay, you can take a on the left side, and this becomes 1 upon a tan theta square. We are substituting the value of x plus a square. So this becomes 1 upon a square tan square plus a square multiplied by a sec square theta d theta in the numerator. So what you can do, you can take a square common, so you are left with 1 plus tan square theta a sec square theta d theta. Okay, so you can just cancel this single a, so we are left with 1a in the denominator, that gives you 1 plus tan square theta and sec square theta in the numerator. Okay, so that gives you 1 upon a. Now 1 upon tan square is nothing but sec square, right? So we'll just write this down, and the sec square gets cancelled. It left with 1 d theta. Now the integration of 1 with respect to theta gives you theta, okay, plus c. What we can do, we can take the value of theta from here. Okay, so the value of theta will be, theta is equal to tan inverse of x upon a. So we can write it over here, tan inverse of x upon a plus c. This is how we have proved the first formula. This is one of the most used formula and the special integral. Okay, now we'll move on to the next proof, where we had I is equal to 1 upon x square minus a square dx. Okay, we have to prove this. Now proving this is very simple, but what you have to do, you have to split this term. Okay, so before splitting it, we will multiply and divide by 2a. Okay, like this. Now further what we can do here is, again we have to take the integration. Now in the numerator and in the denominator, first of all in the denominator we can apply the formula. So here the formula what we can apply is a square minus b square formula, which is nothing but a plus b and a minus b. So the same thing can be applied here, that is x plus a and x minus a. Okay, and this is here is 2a. Okay, now what we have to do here is to split the numerator. Now we have to split the numerator in such a way that your denominator gets separate. Okay, so I'll write this here as 1 upon x minus a minus 1 upon x plus a. Now you can verify this by doing the cross multiplication, that is x plus a minus x minus a upon x minus a and x plus a. So when you solve the numerator, you get x plus a minus x plus a, and the denominator will be same. So plus x minus x get cancel, a and a will be 2a, and again the denominator will be same. So we have got the same thing. Okay, so this is how you can check. I'll just rub this out. Okay, right, now just move on to the proof. Let's just separate this integral. So this will be 1 upon 2a integration 1 upon x minus a dx minus 1 upon 2a 1 upon x plus a integral dx. So 1 upon 2a. Now this, in the denominator you can check, this is a linear term. We already know the formula of the 1 upon x. Now 1 upon x is nothing but log of mod of x plus c. Okay, so here also we can apply the same formula because it is a linear term. Okay, right, so let's just apply it. That will give you log of x minus a minus 1 upon 2a log of x plus a plus c. Now again we can take the 2a common, so that gives you 1 upon x minus a minus log of x plus a, close the bracket, plus c. I'll write this down here. So here we can do 1 upon 2a again. We are applying the formula of the log. So if you don't know, I'll just write this down. Log of a upon b is nothing but log of a minus log of b. Okay, so here also we are dealing with the same thing, log of a minus log of b, that will give you log of a upon log of b. Don't forget to put a mod, because in some cases when you substitute the value of x or the value of a, it may come negative, and the negative of log is not allowed. So to solve that we have to put the mod. Okay, so this is how we can prove the first two special integral formula. Okay, I hope you have understood this proof. Make sure you practice it because it comes for your board exam. Thanks for watching. Make sure you watch the part 2 as well as the part 3, okay, for rest of the proofs. Thank you so much for watching this video.